welcome to Excellence Academy. For today, we studied a very important topic in mathematics known as partial fractions. Now, first of all, by definition, partial fraction is simply a system or a method or a technique of expressing a single fraction or a singular fraction as the sum or difference of several other fractions. Okay, so the idea behind partial fraction is that I'll be given a single fraction and I'll be asked to express that fraction as either the sum or the difference of several other fractions. When it comes to solving problems on partial fractions, there are certain rules that you must follow. Alright, so we're looking at these rules one after the other. Let's look at the first rule called 1. So what's the first rule to look out for when it comes to solving problems on partial fraction? Let's consider rule 1. Rule 1 says if the form or if the factors of the denominator are linear in the form ax plus b, if the factors of denominator are linear in the form ax plus b, then a partial fraction of the form a all over ax plus b exists. Alright, so we have it. We'll take an example to further explain this point. Alright, for first example, example 1, let's resolve 1 all over x squared plus 5x plus 6 into partial fraction. Alright, so let's consider this example. So here we ask to resolve 1 over x squared plus 5x plus 6 into partial fraction. Solution to this. Now, whenever it comes to solving problems on partial fraction, your first task is to consider the denominator. In this case here, my denominator is this. In this case, the denominator here is x squared plus 5x plus 6. Now observe that the denominator is quadratic in nature. It being quadratic means it will have 2 roots. So my first task is to find the 2 roots of this quadratic denominator. That means I'll look for 2 numbers such that if these 2 numbers add up, they'll give you 5. And if they multiply, they'll give 6. The numbers are plus 2 and plus 3. If I add 2 and 3, both be positive, I'll have 5. If I multiply 2 and 3, I'll have 6. So this will now be equal to x plus 2 into x plus 3. So this becomes the roots of this equation, x plus 2 and x plus 3. Now observe that the roots are linear. Linear because the highest power here is 1. The highest power of x is 1. So I have linear roots. So we said for linear roots, a partial fraction of the form a all over ax plus b exists. So next up, after factorizing denominator, your next task is to get the form of the partial fraction. In this case, the form of this partial fraction would be 1 all over x squared plus 5x plus 6 will be equal to a over this first one there. That's a all over x plus 2. Next up, b to this, so plus b all over x plus 3. So this is now the form of this partial fraction. So after we get the form of the partial fraction, what next? So after getting the form there, my next step would be to take the LCM of these two. From here, I have 1 all over x squared plus 5x plus 6 is equal to, now here's what I want to show you, look at it. And here's what you should know. If I'm taking the LCM of, let's say, 2 on even terms, let's say 2 over 5 plus, let's say 4 over 7 for instance. Of course, for these, my LCM is equal to 35. And of course, to solve this becomes 35 divided by 5, it gives you 7. I'll use 7 to multiply this, so it becomes 2 times 7 plus 35 divided by 7 gives you 5. Use that 5 to multiply 4, so it becomes 4 times 5. Now, here's what you should notice. 35 can still be expressed as 5 times 7. So the concept becomes this. If I'm having 2 uneven fractions adding, we can say that the denominator is equal to the multiplication of these two denominators. So my total denominator here becomes to multiply these two. Use this concept here. It means that my denominator here would be to multiply these two. So it becomes x plus 2 into x plus 3. So we have this. Next up, also observe that this term here was what I had here, 2, multiply what I had here, 7. That's this times this, 2 times 7. The same idea will work here. It becomes this one here, a, multiply what I have here, x plus 3. Next up, plus, my next term here was what I had here, 4, multiply what I have here, 5, 4 times 5. So the same concept here becomes b, this, multiply what I have here, x plus 2. So I have this case. Alright, so this is okay like this. This is how we solve, this is how we can easily work this out. Alright, so what next here? At this point here, you can choose to equate numerators. At this point, you can equate. So, equating numerators. Equating numerators, I have that for here. Now, we are equating numerators because the denominators are the same. Alright? If I expand this, I'll get this value. So, since the denominators are the same, let's now equate numerators. So, it means that 1 is equal to, from here, I have a into x plus 3 plus b into x plus 2. Alright, from here now, I'll have to expand. So expanding, I have 1 is equal to a times x is ax plus a times 3 is 3a plus b times x is bx plus b times 2 is 2b. So I have this on expansion. My next task here is to collect like terms. So I will collect like terms. So 1 is equal to, for like terms, I will collect the terms having x. This one has x, this one has x. So ax plus bx. I'm having ax plus bx. I'm done taking the terms that have x. Next up, take the constant terms. Constant terms are simply terms that do not have x. That becomes 3a plus 2b. So I have plus 3a, next up, plus 2b. After collecting like terms, what next? I'll have to factorize. Factorizing. If I factorize this, I have 1 is equal to, these two terms contain x. So factorize the x out. If I take out x here, I'm left with just a. Take out x here, I'm left with just b. So it becomes a plus b. This all into x. So a times x gives you ax. b times x gives you bx. Next one, take out the constant. 3a plus 3b. I have it. Alright, after factorizing, next up I'll have to compare, or you can say comparing coefficients. Comparing coefficients, I have that, first of all, the highest power of x here is 1. So I have for x, if I look at the left hand side from here, there is no x here. That means the coefficient of x here is 0. So I have 0 is equal to, for my right hand side, the coefficient of x becomes this one here. That becomes a plus b. Call this your first equation. Having a plus b. This was 2b. Okay, so plus 2b please. That was 2b. Alright, next one. After x, I have this one as constant. So for the constant, what do I have? For my left hand side, my constant is 1. So I have 1 equal to, for right hand side, my constant is 3a plus 2b. Call this equation 2. So I now have two equations, equation 1 and equation 2. I'll have to solve equation 1 and 2 simultaneously to get the value of a and b. Alright, so solving equation 1 and 2 simultaneously, what do we get? Alright, so I'll solve it using the idea of substitution method. From substitution method, from equation 1, we said a plus b is equal to 0. Move b over here, so a is equal to, b comes and becomes negative b. I'll put a as equal to minus b into the other equation, that's equation 2, into equation 2. And that gives 1 is equal to 3a plus 2b. Fix a here, I have 1 is equal to 3 into a. A is minus b, then plus 2b. From here, it means that 1 is equal to 3 times minus b gives minus 3b plus 2b. From here, 1 is equal to minus 3b plus 2b gives minus b. To get b, divide here by minus 1. Divide here by minus 1. This cancels this. So it means that b is equal to 1 divided by minus 1 gives minus 1. So I've got the value of b as minus 1. Let's get the value of a. From here, from this equation here, we said that a is equal to minus b. That means a will now be equal to minus b is minus 1. Becomes minus 1. That means a is equal to minus 1 gives plus 1. So a is 1, while b is minus 1. So I have a as 1 and b as minus 1. Alright, so if you got the value of a as 1 and b as minus 1, and that will allow me to put the value of a and b back into our general form. Now recall that this was our general form of the partial fraction expression, so therefore put the value of a and b here. This now gives 1 all over x squared plus 5x plus 6 is equal to a. A we said is plus 1. That becomes 1 all over x plus 2 plus b. So b is minus 1. That becomes minus 1 all over x plus 3. So we have this answer. Next up, we have to simplify this. So that means we have that 1 all over x squared plus 5x plus 6 is equal to 1 all over x plus 2 plus minus is minus 1 all over. This gives x plus 3. So this now becomes my final answer after solving. So this is how you resolve this into partial fraction using rule 1. So this is the answer. Alright, so let's solve a second example on partial fraction. So let's say we're given to resolve this into partial fraction. So as I said, your first task is to always consider your denominator. In this case, the denominator here is 3x squared plus 4x minus 4. This is a quadratic equation, and if I resolve this one here, or if I factorize this using the idea of quadratic equation, this will give 3x minus 2 into x plus 2. In our previous classes, we looked at how to evaluate quadratic equation by factorization method, right? If you've not checked it out, just check out the video in the link that we provided in the description of this video. Just go to the description of this video. You see a link provided on how to solve things like this with factorization method. Alright, so let's proceed with this now. So if I look at this, I now have the two roots of this equation. And of course, this they are in linear form. So of course, let's now get the form of this partial fraction. So this will now be 5x plus 2 all over, this is 3x squared plus 4x minus 4. This being equal to a all over this, that's a all over what I have there. This is 3x minus 2 plus b all over this one here. This is x plus 2. So this now becomes the form of quadratic equation. My next task here is to get the LCM. So from here, I will take LCM of denominators. If I take LCM, this gives you 5x plus 2 all over 3x squared plus 4x minus 4 equals, we said from our first example, we said your denominator is usually these two being multiplied. That would be 3x minus 2 multiplying x plus 2. So the next task, this will now multiply this, because divide this one here with 3x minus 2. This will cancel this. You're left with x plus 2. That one becomes a into x plus 2. Next up, plus b. So I'm having plus b into, divide this with this. So x plus 2 cancels x plus 2. And left with 3x minus 2. So 3x minus 2. So I have it. Alright, at this point here, my next task will be to equate numerators. So equating numerators, I have that 5x plus 2 is equal to what I have here, a into x plus 2 plus b into 3x minus 2. So I have this. Alright, next up, expand. Expand the right hand side. So expanding, this will now be equal to 5x plus 2 is equal to a times x is ax plus a times 2 gives 2a plus b times 3x gives 3bx plus times minus is minus b times 2 is 2b. So I have this. My next task here is to collect like terms. So I'll take the terms having x together and my constant. So that means 5x plus 2 will now be equal to, this one has x, this one has x. So it becomes ax plus 3bx. After the one that has x, take out the constant. My constants here are plus 2a, and then this one here minus 2b. So these are my constants. My next task is to factorize. Factorizing, this will give 5x plus 2 being equal to, if I take out x here, I'm left with a. Take out x here, I'm left with 3b. That becomes a plus 3b into x. So a times x is ax, 3b times x is 3bx. Next up I have plus 2a minus 2b. So I have this. Alright. After factorizing, next up is to compare coefficients. If I compare coefficients, my height of x here is 1. So for x, if I look at the left hand side, the coefficient of x here is 5. So I have that 5 is equal to, on my right hand side, I have a plus 3b. So a plus 3b. Call this equation 1. For your constant, if I look at the left hand side, the constant here is 2. I have that 2 is equal to, on my right hand side, the constant here is 2a minus 2b. Call this equation 2. Alright, so I have two equations here, 1 and 2. So my task here will be to solve equation 1 and 2 simultaneously. So solve equation 1 and equation 2 simultaneously. Alright, from 1 I have that a plus 3b is equal to 5. From 2 I have that 2a minus 2b is equal to 2. So solve these simultaneously. Mathematically speaking, this is 2, 2, 2. So it's easier for me to say I can just divide this one. Since they have the same coefficient, I can divide equation 2 by 2. Since they have the same coefficient, this will give divide this by 2, divide by 2, divide by 2. This equation now becomes a minus, this cancels this, I'm left with b minus b equal to 2 over 2 gives 1. So I'm now left with these two equations. I'm left with a plus 3b equal to 5 and then a minus b equal to 1. So I'll solve these two simultaneously. At this point, you can choose to use substitution method or elimination method, whichever one will still work here. Alright, this is still mathematically correct. So if you want to use substitution or elimination from here, you still have the same answer. Alright, let's solve this. For here, I can see that a and a have the same coefficient, so I'll simply just subtract them. If I subtract these two, it becomes a minus a. That gives 0, so a is up. From here I have 3b minus b. Minus gives plus. So it now becomes 3b plus b. That gives 4b is equal to 5 minus 1 is 4. From here I can get that b is equal to 4 over 4 and that's equal to 1. So I've got the value of b as 1. Next up, let's get a. So using any of the equations from here, we said that a minus b is equal to 1 from here. So move b over there means that a is equal to 1 minus b comes and becomes plus b. That means that a is equal to 1 plus, we got b as 1. So a therefore is equal to 2. So therefore it means that a is equal to 2 and b is equal to 1. If this is true now, let's put these values back into a general partial fraction form. So this now becomes 5x plus 2 all over 3x squared plus 4x minus 4 is equal to, say, a is 2. So it becomes 2 all over 3x minus 2 plus b is 1. So 1 all over x plus 2. This now becomes the answer after resolving the partial fraction. So this is how you solve partial fraction using rule 1.